Hello guys, welcome to the fourth workshop, and as always a quick recap for the website. We now have our website updated with the session slides for the third workshop and the video recording as well. And by the time of this recording is taking place, I updated the fourth workshop section on the website, and we have the slides, but we are still waiting for the video recording, of course, after the session takes place. And in today's session, the schedule is we're going to talk about Fluent on HPC. And before diving deep on using Fluent on high performance computing units, let's define, or at least in a very crude way, what's gonna be the high performance computing unit, or what does it consist from. So HPC stands for high performance computer or computing, and some terminologies you will find often something or a name or a terminology used in that industry. It's called cores or tasks, and I'm missing an S here. What do we mean by cores or tasks? We mean it's the physical processor. So for example, the Intel Core i7 processor could have around 7 or 8 physical processors. And nowadays, there is something called hyperthreading. Hyperthreading is that a way to deceive the operating system and let the operating system think that each core is divided into two different cores. In other words, for a Core i7 with 8 physical cores, if you allow hyperthreading, the operating system will see or will feel that it's being executed over a 16-core processor instead of an actual 8 physical core. Why is that? Because the clock speed of the physical processors became very fast, and this is a way, the hyperthreading technique is a way to utilize the hardware in a more efficient way towards the operating system execution. However, Fluent does not use that hyperthreading, and if that hyperthreading is allowed from your BIOS, it should be, or it's encouraged to be deactivated, because Fluent deals with the exact number of physical cores. Okay, in most HPC, hyperthreading is not allowed, so the number of cores that are being marketed or you asks for in your job is exactly the number of processors that you will be executing your Fluent or your process with it. The second terminology is called nodes, and think of the node as if it is a complete separate PC standalone. A PC is composed of processor, hard drives, memory, which is the RAM, motherboard, whatever power supply, etc. And the nodes in the supercomputers, I should have listed a picture here. I'm sorry about that. They are those skewed or high aspect ratio rectangular nodes that goes inside and out from the rack or from the tower of the supercomputer. The second thing is the memory, which is the RAM, and the scheduler. The scheduler is a way or an algorithm or a code that gets to handle the logistics of the operation for those multiple nodes, because the supercomputer is composed of multiple nodes that are being stacked above each other in one rack, and you can have multiple racks to generate that huge computational power. So the scheduler is a tool, it's a Linux tool that allows anyone or us to deal with that supercomputer and to sort its logistics. And moreover, it prioritizes the jobs, because, for example, an available supercomputer at UCI could have around 500 or 400 users at the same time trying to submit jobs. So which one is so in other words, how we're going to solve the problem for allocating resources for the asked jobs, and each job, for example, could have 50 cores, 100 core, 500. What's going to be the way of managing that hardware that we have and assigning the jobs order? Based on that, another thing that the scheduler do is that it can generate queues. So for example, you can submit your job for a queue where that queue is free, it's not charged, it does not consume anything from your computational quota at UCI, or you can submit your job at a charged queue where you are being charged computational hour as long as you are executing your simulation or your code. So for example, having the charged queue, the scheduler prioritize or gives priority for the charged queue before more than the free queue, and based on that, if you submit a job for the free queue, your job might be terminated without any precaution or any notice before the termination. However, if you submit a job to the charged queue, your job will not ever be terminated until it's finished. And this is how the schematic diagram for the HPC works. These are us on our laptops or PCs, and obviously that huge facility, which is the high performance computing unit, exists in a different place. We don't have access to that. There is no turn on button or shut off or shut down or sleep. We don't do that. It's a huge facility, but we would like to access this supercomputer. The way we do it is that we communicate from our laptops to something called login node. And now we know the term node, which is kind of a separate computer or a separate case inside the rack. That login node, you communicate to it through something called SSH, and the abbreviation for that, or the common word of that, is that you are sharing or SSHing your supercomputer facility or supercomputer cluster. And the SSH stands for Secure Shell Over Network. It's a protocol that you can communicate with another computer in a secured way over an unprotected network. Okay, and to be able to shish the HPC at UCI, you must be logged in, or you must be accessing the UCI network, or in other words, you must be on campus getting your wireless LAN from any router or any machine that, or any plug, Ethernet plug that is on campus or in the family housing. If you are not on campus, this does not mean that you are not allowed to access the supercomputer. You can, but however, you must set up the VPN that UCI asks you to do it, and based on that, when you set up the VPN, your computer will be as if it is getting internet from UCI's network. Then you can access the supercomputer through the HT protocol. After you log into the login node, you can submit a job to the scheduler. When you are asking the HPC to perform a specific job for you, you submit that job to the scheduler, and then the scheduler distributes or prioritize, as we explained a little bit earlier, the jobs on the different compute nodes. So this means that the HPC doesn't have only compute nodes, it has compute nodes and it has login nodes, and at the same time it has something called storage nodes. Why is that? Because the compute nodes are mainly designed or available for crushing numbers. Think of them as if they are huge number of array processors working simultaneously at the same time, and a large memory or a large RAM that allows you to do, for example, a very small DNS simulation at a very small Reynolds number. But however, the size of the data that you would like to store is very huge. So that's why we have a storage node or another node where you get to store your data. Each UCI user get around 1 terabyte for free on the storage node. But if you would like to extend them or increase them, I think you can do that if you are in need of more storage. They allow that. And from the login node, if you are logged in on the login node, you will find that you can access those compute nodes in two different ways. One of them is called interactively, or in a batch mode, or in a background mode. What do we mean by that? We mean by that, if you are trying to compute something that requires some interaction from you, as if you are using Fluent software on your local PC, the HPC allows you to do this, but for a small period of time and with small hardware capabilities. In other words, if you ask the HPC to give you an interactive node, you can do that. You can open your case file and you can do everything interactively online. However, HPC does not recommend, or actually will cut off any interactive session after a specific amount of time, because HPCs are not built for that specific purpose. HPCs are built for crushing numbers without any user interaction. That's the main purpose for having a supercomputer in any facility. So, as I was saying, it's designed for crushing numbers with the minimum. It's designed for crushing numbers with minimum. Sorry, there is an extra number here, with minimum number of user interaction, with minimum or no user interaction while running jobs. Okay, I'm sorry about that. There is an extra number here. And as I said before, it's accessed through secured shell network, which is the SSH. Now, this is a very brief explanation about what is the HPC, and to be able to explain it more, I will show a roadmap for how to execute Fluent on an HPC. But before doing that, I would like to mention that UCI has a very good HPC. It's called HPC3 now. And these are its specs. It has 200,000 batch accessible nodes. So in other words, it has 2,000 batch nodes, which are the compute nodes. These are not interactive nodes, as I said. And they can have around 9,000 total cores. 1,300 from them are AMD EPYC, and 8,000 are Intel processors. And you have around 57 terabyte of memory, not storage. This is memory. This is considered as RAM. So if you are having a very large problem, you can actually ask for a terabyte of RAM, not of storage. Okay, so it depends on the size of your problem. And they have 3 login nodes, and they have GPUs as well, graphical processors. They have 13 nodes with that NVIDIA card, V10, and NVIDIA A3 and NVIDIA A10. GPUs nodes, I think they are not free. There are no free jobs submission to HPC through the GPU. But however, the good thing about the charging is that, and I will mention this in the HPC, when you are assigned to a lab, each lab gets kind of a free quota at the beginning of the year. That quota could be around 200,000 computational hour. Once you finish this, or you deplete all your quota, then your advisor or your lab must buy again more computational time by paying some amount of money to the HPC. Those charging and logistics are on the HPC website. Just Google UCI HPC3. You will find a very detailed website through the UCI. It's called the Cyber Security Research Center, something like that. but you will find a detailed website for the HPC3, and it has all the information. And what I'm trying to do is to summarize the most relevant information for you to submit a job, and highlighting or emphasizing how we do this specifically for Fluent. But that website is more than enough, and it contains all the information, all the how can you be charged, how to contact them, what are the available modules or software. All of the information are available there. And there is a very nice video. It's called Introduction to HPC3. This is a video done by UCI, because a couple of years ago, like 1 or 2 years ago, UCI used to have a specific HPC, and then they made a transition to a new one because the old one was outdated and they had to retire it. Once they were doing that transition, they had this very like hour-and-a-half video interacting with different researchers and students here at UCI, with a very powerful presentation to explain how the new HPC3 works, how to submit a job. Most of the time, you will find some information that could be irrelevant for you, because they were trying to let the current users, where these users are the users for the old HPC, to be very familiar with the new one and have a smooth transition. But this might help you even if you are a new user for the HPC. Okay, so let's see how we can execute a Fluent job on HPC. Let's consider this is our personal computer, and this is the high-performance computer. Executing Fluent on a high-performance computer requires these two hardwares. You need your laptop and you need the supercomputer. Your laptop is composed of a couple of hardware: CPU, which is a core, RAM, and SSD, which is the storage where you keep your files. And you can run Fluent using the graphical user interface on your PC. And that's actually what we have been doing the last couple of workshops. We were opening Fluent on our local PC using the graphical user interface, where you get to interact with Fluent graphically. Actually, it turns out, or you could run Fluent on your local machine using the text user interface. In other words, everything that you can do using that graphical user interface is being done using that text user interface, where you don't see any nice graphics, but you are just dealing with text lines, and Fluent asks you for questions when you ask it to perform a specific task. And doing that, running Fluent from the text user interface, you can do it into two different modes. You can do it interactively, where you write a command and Fluent answers and waits for your answer, and then you answer, and it's kind of as if you're chatting with ChatGPT, but you have to understand its commands and the questions that's going to ask you. So this is the interactive way of doing it. And you can do it on your local PC as well in a batch mode, where, for example, you could ask Fluent, please open that case, solve 1000 iteration, and once you are finished with 1000 iteration, write that case in data and then exit. This whole process will be done in a sequential order without any interaction from you. And that's a very important, or a key point in using Fluent on the HPC. Why is that? Because what we will be doing actually on the HPC is just running Fluent in a batch mode on a Linux system. So if you have a Linux system or a Linux software, and you get to know, or you are able to run your Fluent in batch mode on your Linux machine, this is a very big progress, or a very good help for you in running Fluent on HPC, because all what you need to do is just migrate this data to the HPC, and then ask HPC to please do or perform the same task that I were doing on my PC. Obviously, the big difference is that here you get to do it with 6 cores, 18 cores, I don't know. Here you get to do it on 50, 100, 500, whatever number of cores you are asking for. So that migration thing that I said requires us to dive deep in the HPC. Again, as I explained before, we have the login node and we have the interactive node. At UCI, we have a couple of interactive nodes where you get to interact with the HPC, and you can run Fluent interactively on HPC as if you are running Fluent interactively from the text user interface. So why I'm just highlighting the text user interface while dealing with the HPC? Because the HPC is not very good at processing graphics. Actually, it's built, as I said before, only for crushing numbers. So if you would like to interact with it, you can interact with it through text. And believe it or not, every interaction that is gonna be done from your local PC to the HPC actually is being tunneled through the network that you are connected through it. So as if you are sending data and receiving data at the same time. So this this tunneling or this communication thing it does not make it very easy or an easy job to send graphics or pictures or videos instantaneously at the same time. It's as if you are streaming a video, YouTube or something like that, and you want to do it interactively, because you don't know what's going to be the second frame that you would like to send to the local PC to watch it, okay? And again, on the HPC, you have the home directory. This is, think of it as if it's the C directory on your Windows machine, and it's the home directory for your Linux system. And you have a storage directory where this is a different directory that you get to store your huge data. And then we have the workhorse for the HPC, which are the batch nodes. In those batch nodes, you have multiple cores and RAM, as we explained before. And these two get to communicate with each other. As I explained, the communication is done in two different, not ways, but in two different steps. The first step is that you would like to log in to the HPC. How do you log into the HPC? You use your command window in Windows, the CMD, or you use the terminal in Linux. For example, I'm showing here an example for Linux because I'm using Linux in most of my simulations and dealing with the HPC. So there is a way that you can open a terminal or a CMD in Windows, that black window, and you write a magic line that allows you to log in one of the nodes of the HPC. And once you are logged in, you will see login I5, which means that the login node number 5, and you get to see some specific information. Now, whatever you are doing on that screen, it's actually being done or executed or performed where? On the HPC. You are just seeing it on your local PC, okay? The second step is that you would like to transfer your data, the case file, the data file for Fluent, or whatever files that you would like to transfer to the HPC. And this is being done through a software called FileZilla, where you set up your login credentials for the HPC on that FileZilla. And once you open that FileZilla, as I'm going to show you, you will see your local storage on your PC, and at the same time you will see the HPC storage or the directory that you are allowed to see on the HPC, which is your home directory, okay? You can then transfer whatever files to your home directory. So now the file is available there at the HPC, and through the communication process, you can go and submit a batch job. Through your login node, whatever you are writing here on that command window or terminal, and the files that are already there in your home directory, you can submit in a way or another a batch job, where this is a job you don't get to interact with it at all. But doing that requires you to go through the SLORM. And what is the SLORM? The SLORM is the technique or the technology that the HPC here at UCI is adopting as a scheduler. The schedulers for HPCs are kind of a standard industry. HPC, the old one for UCI, used to use something called SGE, which is Sun Grid Engine. That architecture or that way for dealing with HPCs became very old and it's outdated, and most universities and companies all over the world now are transitioning to the SLORM because the SLORM is being considered as the new technology or the newer version for dealing with HPCs. Actually, if you just googled SLORM with HPC, you will find tons of manuals from all over the universities: Stanford, MIT, UCI, of course, UCLA, Texas, Austin University, Texas Austin. All of these universities, most of them have a SLORM scheduler, and you get to deal with that SLORM scheduler to submit a batch job. Okay? So this is the process. If anyone figured it out, you will be able to do a Fluent job on the HPC. But however, we can, or as we can see, not however, as we can see, we can divide this process into two different animals. One of them is dealing with Fluent in the text user interface interactively or in batch mode. If you get to do this on your local machine, then running the same simulation on the HPC is just a matter of 2 minutes file or 2 minutes submission job to the HPC. Okay, so that's the big thing. So I will start with it, how to run Fluent using the text user interface locally on your machine. So the TUI is the Fluent text user interface. It's equivalent, and actually it's more powerful than the graphical user interface. For example, some pro options are not available or cannot be seen in the graphical user interface. You have to access it through the text user interface. And on top of these options are the periodic boundary condition or the cyclic boundary condition. As if you recall last time or the time before when we introduced the type of boundary condition, there used to be the periodic one where you say as if you are as if you are connecting two different boundary conditions hypothetically, and this connection you cannot declare it just from the drop-down menu from the Fluent options. And why is that? Because most of those hard or most of those pro options that are related to the solver, in types of initialization, type of periodic conditions, Fluent does not want these delicate to deal with options available at the nums or available for use or disposal for anyone who is trying to use Fluent as a beginner, because they will ruin the solution if someone is not know what he or she is dealing with. So that's why they are being hidden in the text user interface. Okay. The TUI commands. This means that we need to know or we need to deal with some commands. Please read mesh, read case and file. What should I tell Fluent to perform a task? To do this, one needs to go to the ANSYS Fluent text command list. That's an open information for us because we have the license here at UCI. Just open Fluent, click on help. You will be redirected to a website where you can actually download that PDF. It contains all the commands that Fluent has in the text user interface. The good thing, or some examples about the commands, let's see here. One of the most famous, or the command that you will start all your simulation with, are RCD. What's RCD? Read case and data file. That's it. And that's the name of my file. And I have the extension .ces. .ces is the case extension for Fluent. And then in that case, I was trying to have a specific simulation, and that specific simulation, I was trying to change the angle of attack of the flow field. So I asked Fluent to write case and data. Please write that case and data again, but with just a new name. So now in that directory that I am in, I will be having a file with a new name. And then I will ask Fluent to go to mesh, and then under mesh, please rotate the mesh with 4 degrees in that coordinate where I have 1, 2, 3, 4, 5, 6. I have 6 coordinates, and it's kind of not that wise to have 6 coordinates, but that's how Fluent deals with it. It should have been only 3, but I don't know why they have another 3.
Translation and rotation as well.
Yeah, but I specified rotate, so I don't know. So it takes time. It takes time, and you get to do a couple of examples till you see what is the result. And then I went to solve report files, edit results. This is the file name that I'm trying to write, that I write online while I solve. And then I write again the case and data. And then you see here, yes on its own, like I'm just trying yes. Why is that? Because when I ask Fluent to write in case data again, I write this case and data before with the same name. So what will happen is that Fluent will ask me, would you like to overwrite? So then I write yes. Why is that? Because I'm showing here you actually a way of dealing with Fluent in a non-interactive way. But if you are gonna write this command while you're doing it interactively, you will see a message. Would you like me to override? Then you hit yes, okay? But I just thought that this is a good idea of listing a couple of commands at the same time. Then please read it again. I don't know why I read it again after I wrote it, but that's okay. And then solve, initialize the flow field, solve, iterate. I just like to do one iteration, write it again, yes, quit, go outside everything, exit. Would you like to exit? Yes, I would like to exit. So with time, you get to know most of these commands and how you can deal with it. This is another command where I was trying to change the CFL number. Do you remember in the coupled solver when I mentioned the CFL number that acts as an under relaxation factor? I wanted to have that relaxation factors to be unity for all of my variables. So for the CFL, I changed it to unity, and for the turbulence as well, I was using the K omega model. I changed it to be unity. So this is kind of the last phase or the final phase of solving my CFD simulation. I got a convergent solution for relaxed variables, but I don't want to keep this under relaxation because I would like to be solving the specific equations, if you recall from what we defined last time. And then I was changing the output variables and etc. So it doesn't take a lot of time to know what you're trying to do. And the good thing about the text user interface is that you don't have to go immediately or direct straightforward to that black window to deal with Fluent, because I know it's not user friendly and we're not used to that, mainly new generations like me. We like to see a window. The good thing about Fluent is that all of the commands that you can use it in the text user interface, you could actually write it here in the console inside the graphical user interface. So for example, you can open Fluent, and instead of going to File, Read, Case and Data, and then select the file that you would like to have, you can just go here and write RCD, the name of the file. So actually sometimes I face hard like times in finding the specific command that I have to deal with in the text user interface. So I keep do some trials and errors here in the text user interface of the console and just making sure it's being changed in the graphical user interface. So I go to that window, oh, and I make sure, oh, go to controls, oh, I changed the under relaxations to be 1. Now the under relaxation value must be 1. So this command that I have written here changes the under relaxation to be 1. Okay, so I'm just trying to giving you some experience of how to do it, or share my experience with you. And as a demonstration, because I don't want to pack all of the workshop or explanation at the end of the session, I would open Fluent now with you in a graphical user interface. I will try to have a couple of commands in the console window, and we will see how Fluent can, what Fluent can do and reply to us, okay? With what? So what I'm gonna do now is that I'm gonna close my current session of Fluent. I'll press OK, and let's go to the commands are applicable for Windows and Linux. The commands are for Fluent. These commands, the text user interface commands, are being written and implemented inside the Fluent software. Even if you are dealing with a command window, if you are having a terminal window in Linux or a black CMD command window, you cannot write any of those commands until you load Fluent, or in other words, until you hit Fluent and you will see the load message of Fluent. And doing so, this means that you are now inside the Fluent software. These commands are only available inside the Fluent software, okay? Now I will open Fluent. I will select my directory, because one must open it from the same directory that he or she is interested in, or the case file are there. I will go to Fluent case files and click open. Now I would like to show you something that's very helpful when dealing with the see everything that has been written here. Welcome to ANSYS, ID host name Nabil Yoga, that's my laptop name, the number of cores, 2 or 4 cores. I asked for 2 cores if you recall from the online or the previous window, and a 2D simulation, the selection options that we used to, and the MPI option is called IBM MPI. Whatever is written here is actually whatever is gonna be written if you are dealing with Fluent in the text user interface only. So if you're trying to open Fluent just from in a text user interface environment, you will see the same exact messages from here. That's why I urged at the beginning of the workshop that whenever you are dealing with Fluent in a graphical user interface environment, please always keep an eye on that console, read it, familiarize yourself with what's being written there, because the transition to the text user interface will be a simple task for you then. Now I can go here and just read case and data and select, for example, that case which is cavity. This is a graphical user interface. I don't want to do that. I'll just go here and say RCD, read case and data, click cavity.ces, hit enter, and that's it. Fluent is reading the case and data. And what's being written here was going to be the same message that will be written in the console if I would just click on read from the graphical user interface, read case and data. Let's, for example, say I would like to initialize my solution, okay? And I don't know the specific command that I should write. For example, here, while I was showing that, to initialize a solution, I would like to go to the solve where solve is kind of thought of as the drop down menu, and under the solve I have initialize, and from the initialize I asked initialize flow field. Okay, so you get to write this in one single line and hit enter, you'll be able to initialize the flow field. But what if I don't know that, or I didn't bother to the text user command and I would like to do it by myself in Fluent? It turned out that Fluent actually has a user interactive text command inside the console, even inside the graphical user interface. If you hit enter once, you will get that. What's this? It says adapt, file, mesh, solve, iterate, display, define, etc., exit. Under each menu of those, you will get all of the options that you can actually do through the graphical user interface. So for example, I would like to go for solve, and now I'm under the solve menu. If you hit enter again, you get everything. You get initialize, you get report files, you get the monitors. For example, you could go to the monitors and change the, for example, the convergence criteria. You have the convergence conditions. Everything that you can get from under the monitors here, you get it from there. Okay, so for example, I will go for initialize, and the good thing about it is that you don't have to write the whole word. So if I just hit in and there is no other option other than initialize, and I will hit enter, it will go to the initialize sub window, and I hit enter again, I have the different types of initialize. I will go for initialize flow, and that gives you a reason why in my presentation I had in-fl, which means initialize flow. It's the abbreviation of that thing, initialize flow. And just go here, and the flow is initialized. For example, I would like to do a hybrid initialization, which is listed here, because if you remember from the initialization, you get two options, a standard initialization or a hybrid initialization. I would like to do a hybrid initialization, so I will just write HYB and then in, which is initialize. You will see Fluent is asking you, says current data has not been saved because I loaded the case and data, and it's saying including solution blah blah blah. Do you want to discard the data and proceed with initialization? Now this is the time when you write yes, and this was the reason I had yes. This was the reason I had yes in my files that I was showing to you. Okay, just having yes, and then it applies you with a nice error. It says this case has only inlets. So obviously, if you have only inlets, you cannot have a hybrid initialization. To have a hybrid initialization, you need an inlet and a pressure outlet, and that was a learned message from you to you. Now, if I would like to go out, I'll just write quit. I go one sub menu. I go back to the menu, quit, and I can write case and data. I can do whatever, anything I can do. Okay, or I would like to do. Now, the interaction that is being done here in the console is going to be the same interaction that you are asked to do while dealing with Fluent in the text user interface interactively. If you would like to deal with Fluent in the text user interface interactively, then whatever you are be doing here, you will be doing it, but just instead of what's being written here is inside the graphical user interface of Fluent, it will be written inside a command window on Windows, or a terminal window, just a black window with some letters, and that's it. Okay, so I totally recommend that get yourself familiar with the text user commands, what you are trying to do. Most of the time you will see that you don't need more than just read case and data and solve and iterate. If you are just trying to send your simulation to the HPC, you don't want to deal with it interactively, you just read case and data, please do this number of iterations. Once you finished, write case and data and then exit. And as I'm going to show you, this will be my only go-to commands whenever I'm sending a job to the HPC. Now, enough about that, and let's go back to the presentation. Fluent in TUI mode only. Now we will be using Fluent in a text user interface only, without the graphical user interface. Doing so interactively, first of all, you need to open Fluent, because remember, in the previous example, I opened Fluent from the shortcut. So I would like to do that from a command window. Like I don't have now a shortcut or anything. I would like to open Fluent. What should I do? You should be in the directory where Fluent is installed, or in HPC you should load the module, okay? And just keep that in mind. And then inside your terminal, inside your black window, where you are gonna open the terminal, which is that black window in Linux, or the CMD, or a terminal as well in Windows, you will write this line. However, this line changes based on your selection from the option menu before loading Fluent. Remember, when we hit on the shortcut, there is a small window that asks you 2D simulation or 3D. Here it is, 2D simulation. Double precision or single precision. Here it is, DP, double precision. If you drop off DP, this means that you are opening Fluent in a single precision. If you are opening a 3D simulation, then this must be a 3D. Now, what's minus T2? Minus T is the letter that declares after it the number of processors. So 2 means that open Fluent in a parallel mode with 2 processors. Okay? Minus G is, please do not include the graphical user interface. If you actually remove that minus G, Fluent will open the graphical user interface as if you opened it on a Windows or anything, and you will see it, okay? And the graphical user interface will open, and then that welcome message will be detailed or be seen on the console of the graphical user interface. However, we don't want that anymore. We want to deal with it in a text user interface environment. So we include the minus G. And this command works on Windows and on Linux as well. However, I will be showing only the Linux. Now you get to use it in same way as for the graphical user interface plus TUI commands. As we showed earlier, consider yourself what you are trying to write here is exactly what you have been writing on the console for the graphical user interface. So it's obviously a big plus, or a big step, or a recommended step to familiarize yourself with the text user commands inside the graphical user commands. Now, what if I would like to use it in TUI mode, but I don't want to interact with it? Like, even if Fluent is gonna ask me a question, would you like me to overwrite? I need to have in my mind that sequence of orders that I'm gonna implement, and have the corresponding reply ready and written in a sequential order, so Fluent's executed step by step without any interaction from my side. To do so, you need to write a sequence of your text user commands that you actually are gonna enter it in an interactive way, store whatever, anything that you have to write, okay, in steps, and then, thanks for the team viewer session, okay. And then after you write the sequence of the TUI command to be executed, you create something called the journal file. That journal file will be the input to Fluent. And what Fluent will do is that it will execute this command sequentially as if you were writing it and interacting with Fluent. However, this list of commands are already pre-written and stored in a file. You don't get to change it once Fluent read what's inside here. And as you can see, this is the most important, or the most of the time the journal file or the input file that I go to, which is just please read my case, solve it. After Fluent finishes or executes the 10,000 iterations or whatever, write my case. Would you like to overwrite it? Because it will ask me now, would you like to overwrite? I will hit yes, and that's it. I'm done. I'm good to go. And then please quit. I like to have multiple quits, and then exit. Would you like, it will ask me, would you like me to exit? I will just say yes, and then Fluent will terminate, and that's it, etc. But how I tell Fluent to use that input document or that input file, it's through this line. It's going to be the same line based on your problem. Fluent, please open Fluent inside the terminal. This line is written inside the terminal. Fluent 2D double precision, the number of cores, no graphical user interface, and please take the input, I stands for the input file, as to be the journal underscore HPC3 underscore dot journal. This is the name of the journal file that I already created. In other words, think of all the commands that you wanted to perform here in an interactive way. Store these commands in a file in a sequential order, and then transform it or make it or group it in one single file. This file will act as the input to Fluent. Okay, and this is the most important step in dealing with HPC, because running Fluent in a batch mode, which is a background mode, without any user interface or without any user interaction, is going to be the same way for running Fluent over the high performance computing unit. Okay. Demo. I will go for demonstration. I will show you Fluent in TUI and Fluent in batch mode. Now, I don't like to use Windows with terminal, to be honest, and most of the time I use Linux for CFD stuff. So I have my Linux machine at my lab. However, I access it through TeamViewer. That was just closed down. So I will show TeamViewer now. I will access my Linux or Ubuntu machine. That's what you see on my machine. Okay. This doesn't want to close, never mind. Okay, so the worked example. Let's consider now that I have my case and data file here. These are my case and data file. And I am inside that directory, or I would like to open a terminal inside that directory. All what I'm going to do, I'll just right click, open in terminal. So I'm inside that directory, CFD workshop. This is my home directory, and under home, I'm inside CFD workshop. And I will just write Fluent. You won't be able to write Fluent in a clean, fresh setup Linux environment like that and open Fluent. You have to go to a specific directory where Fluent is being installed, and then open Fluent from there, and then come back to the current directory to open your file. However, I edited my Linux system in a way just to make it in a more convenient manner, that when you just write Fluent in any command window or any terminal, you will open Fluent. Okay. Now, as an example, I'll just write Fluent and hit enter. See what's happened? It opened the graphical user interface. And it's asking me, what are you trying to do? 2D, double precision, whatever, etc. I don't want to do anything. I'll just hit cancel and it will go away. Now, let's, for example, I would like to open it in the text user interface interactively. I will write Fluent, and I want it to open in two-dimensional, double precision, with number of cores 2. And please do not open the graphical user interface. And I would like to deal with it interactively, so I'm not gonna give it any input file, and I will hit enter. See, it's opened. Here it is. Nabil precision 2 out of 6. This is the name of my machine that I'm over it there. This is the welcome message. Welcome to ANSYS Fluent, everything. And I would like to read case and data. I would like to read case and data, cavity, and hit enter. Now it's reading the case and data, reading the mesh file, everything that we have written in the text user interface inside the graphical user interface on the Windows, we can deal with it here and we can do whatever we like. Okay, so let's, for example, we would like to initialize it. Here is the menu. I will go to solve. Under solve, hit enter again. We have initialize, and I have initialize flow. So I will go to initialize flow. Now the flow is just initialized. Would you like me to quit, go back? I would like to iterate. It will ask you for the number of iterations, how many number of iterations that you would like to perform. For example, I would just say 10. See that this is the console menu with the updates. It's showing you the residuals and whatever anything that you are asking Fluent to plot or to print in the console, as if you are solving it on your graphical user interface. Now I can write the case and data and file if I would like to do. I'll just quit, write case and data, cavity. Would you like to overwrite? Yes. That's it. Quit, exit. It goes out and I see my directory again. This means that I'm outside Fluent. So this is dealing with Fluent inside the text user interface without anything. Okay. Now, what I just did without the initialization or anything, for example, I have my case ready, initialized everything. It's time to crush the numbers. So the only thing I need is just please read case and data, perform 10,000 iterations, write it, exit, thank you. So this is my journal file. Here it is. Right, case and data. I created that file, just a text file, but you you change the extension to be .jou. It's the journal file. Read case and data, solve, iterate, write case and data, yes, thank you, that's it. So let's go back again to that terminal. And now I would like to open Fluent, but just giving it that input file. So Fluent 2D, 2 cores without graphical user interface, and the input file is this file name. Okay, and I will hit enter. See, everything will be done automatically. It's reading the mesh, it's performing 1000 iteration, it's saved, everything is done. It's just a very simple case and the processor there is powerful, so everything is going very fast. Now all of that is done. Like this is the number of iterations, this is everything. Okay. Now there are some tricks and some knowledge and some experience. When I open Fluent in this way, whatever is being written in the console or whatever being written in the output, it's not saved. It's actually inside the terminal. So if I hit close, it's boof. I didn't know what happened. Everything gone. Okay, so I cannot debug it. So that's why it's recommended to open Fluent in a way where you can save your log file. So for example, if you would like to run Fluent in a 2D way, double precision without the graphical user interface, asking for 4 cores, and you would like to hide the console, you don't want to see what's being written by the Fluent inside the terminal, but to be saved in an output file, you just have this log.out. In other words, if I take this, okay, or if I change my line that I actually did in the terminal, I will open the terminal again and go here, and instead of having just an input journal file, and my log goes poof when that thing ends, I will do this. I will append this line here and hit enter. Now, whatever is being written, now you don't see anything being written here. Why is that? Because whatever Fluent is gonna write here, instead, you will have it here in a logout file where you can have everything and it's being saved and stored. Okay, so this is a very important thing, because running Fluent in a batch mode means that this terminal will close away automatically on the HPC when you are done. So every text that is being reported to you, or you are not saving it in the same directory, is going away. Good luck. You don't know what has happened. Okay, so this is a very important information. Now we are experts. We know how to write, to open Fluent. We do it in a TUI command, in a TUI mode interactively, and in a batch mode. It's time to transition whatever you have already done to the HPC, because my processor now, or my local machine, is not that good. So most of the time you will find yourself needing only a journal file, which is the input file, just composed of this. Read the case and data, perform this number of iteration, write it, yes, overwrite, exit, thank you, and that's it. You won't need more than that. Okay, because, for example, the evolved journal files that I showed you in the presentation, for example, here, let's see, cluster HPC, which I showed you earlier here. No, here or there. I don't remember. Where did I show you? Yes, for example, when I was trying to familiarize you with the commands, I was actually tricking you, and I was showing you an input journal file. What's that journal file? This is read that case and data. I would like to change the angle of attack, save it with a new name, and then after you save it with a new name, please go to mesh rotate, change the angle of attack with 4 degrees over that axis, change the report file names, because I was saving values while I was running the simulation in a live mode, change the name of the file, and then please go out, write it again, read it again, initialize it, perform one iteration, because I would like to perform one iteration for that file to be written on my local PC, and then write it, and then exit, and that's it. This type of scripting of the journal input file is very good if you are dealing with a huge number of cases. Why is that? Because, for example, this was a simulation for an airplane that I have been showing throughout the workshop, and I'm asked to generate the CL coefficient with different angles of attack. For example, 0, 2, 4, 6, 8, you name it. So I have around more than 15 angle of attack that I have to compute it. So I have 15 cases. However, I'm not asked to compute it at one single velocity. It was at different velocities. So I have a matrix actually. At this angle of attack, I have different velocities, and another angle of attack, I have different velocities. So you get to choose. Either you're gonna generate the angles of attack and change the velocity, or generate the velocities and then change the angle of attacks. Even if I'm doing the simulation at the same velocity and changing the angle of attack, that will be the wiser solution. Why is that? Because when I do the simulation at 0 angle of attack and I reach a converged solution, this means that when I change my angle of attack, the initial solution would be the converged solution of the previous one. So this would save you a little bit. So if someone's trying to do this through the graphical user interface, you have to be very sharp, very focused, to be honest, to go all of these node, all of these menus. And do not forget to change the value for the results, for the output value, the name of the file, the angle of attack, etc. So it takes a huge time and focus to do it. And the bad thing is that you get to do it to open Fluent, click those clicks at each case. Just count these number of clicks and the number of cases that I have. It would take me, I did it once, it took me around complete day. And I was sure that a couple of cases were wrong and I missed something. That's why I thought that I have to do the homework, and I have to write this sequential file in a batch mode or even in an interactive mode, I don't care. But this file, what I do is that just I keep it, and let's say I would like to do the same thing after the 4 angles of attack converge, and I would like to do 8. All what I'm going to do is that I open this text file, I change 0 to 4, which means that read 4, and then I change 4 to 8, and then that's it. And actually this file is stored on my thing, on my computer. I copy it 15 times, and I open Fluent serially, boom, 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 open that, open that, open that. I do it in 2 minutes. So it's a huge difference to use Fluent in the text user interface compared to the graphical user interface, especially if we're going to use it extensively to perform a huge amount of number of data, as I emphasized before. So now, up to this point, we became experts. Yes, now you're expert, believe it or not. Yeah, you're expert. And we know how to run Fluent using the text user interface in an interactive way and in a batch mode. And we know how to do it on our PC. And I totally encourage you, even your case is very large, like one single iteration would take you 4 or 5 hours on a 3D simulation just to do it. Just do at least one single iteration on your directory, on your local machine in a batch mode. Because once you reach that, the next step is going to be is that please take that case file, that data file, that journal file, the input, take those 3 files, upload them magically to the HPC, and then inform the HPC to open it in a batch mode and do the simulation. And that's what I'm gonna do now, or I'm gonna show you again. So this is again our process. We actually finished this now. We can do this, so we know how to perform it on our local PC. However, we need to do that communication thing, log into the HPC, and then transform our files from our local hard drive or solid state drive to our home directory, and then submit a batch job through the SLARM. This asks for 3 different steps: communicate or log in, transform or migrate files through FileZilla. While you are logged in and your files are there, the 3rd step is please submit a batch job to the SLARM. Okay, so if you follow the blue arrows from your local PC and the HPC, you will be able to perform one single job in a batch mode on the HPC. So for the HPC, it requires a couple of things from us to be able to deal with it. The first thing, that you need an account. So it's an easy thing, but you need an account. And to have an account, you must be assigned to a lab. In the old HPC, it used to be I think you are assigned to a lab without. Have you listed the lab quota? So what's going to be the quota that you're using from? I don't know. I think that's not. Who created the account for you? Yeah, but when you send the account, you didn't mention the lab. You didn't mention Professor Taha. didn't mention any PI. Professor Taha's email was not in anything in your, I don't know. So when I created the, maybe they changed the policy, but when I created my account, they informed me that I must be assigned to a lab, because the quota, the free quota, or the not the free quota, the complementary quota is being assigned on a yearly basis for the lab. And as a student in the lab, you get to charge the quota of that lab on HPC. If you are gonna submit only jobs to the free queue, where your job might be terminated at any time, that's okay. But I don't know that piece of information, if that you can generate an account on the HPC without being assigned to a lab. We can go and double check this information on their website. To create an account, just send them an email. Just go to HPC3 UCI or whatever. This is my UCI net ID. I would like to create an account. They will create an account for you, and your UCI net ID will be the main keyword in dealing with the HPC. So let's see how we can log into the HPC. To log into the HPC from the terminal or the command window or whatever, you need to write this line, SSH, replace that with your UCI net ID, whatever it's your UCI net ID, and then at hpc3.rcic.uci.edu, and then hit enter. And while doing so, you must be connected to a network that is on campus, or activating the VPN or UCI VPN. When you do so, this is my screenshot. I go from my machine, and my UCI net ID is nkhalifa or nkhalifa at hpc3.uci. When you hit enter, it will ask you for your password. The password is your UCI net ID password. It's not your UCI email password. It's UCI net ID password. The password we enter to validate that do thing. When you enter that password, and then it redirects you to the DO or whatever waves of second factor authentication. And by the way, actually, to log into to HPC, you need the DO two-factor authentication. It will ask you do push to, this is my phone number 5622, and you must hit enter here. You have only one option. You press 1 and you hit enter, and then you will get a do notification on your mobile. Then you allow access. Once you allow access, then you will be logged in on the login node, and you will see this type of information. So this window will be on your local PC. However, what's happening inside that window is not on your local PC. It's happening now on the HPC. Okay, you will see here, whatever line I'm writing, it's Nabil, the user Nabil, at the name of the machine, Nabil Precision 36. This is my name of the machine, my Linux machine. But after you log in, you will see here nkhalifa, which is your UCI net ID, as I'm going to show you in a second. And then you will see the name of the login node, because you are now inside the login node. Okay, so now you just logged into the HPC3. What should I do now? One needs to make himself or herself familiar with a couple of SLARM commands. As I showed earlier, the SLARM is this type of the scheduler that UCI is using here. And by the way, those commands are not unique to UCI. Those commands are generic commands. They are for the SLARM scheduler. The SLARM scheduler is a third-party thing that is being developed by a company, and UCI is using. Okay, so if you found a tutorial for another company or another university that's more convenient to you, you can actually use it or study it, whatever it is. Okay, and here we're going to spend some time. The first command. These commands, you get to use it inside that black window. So after you are logged in, you can use any of these commands while you are logged in inside that terminal. You can use sinfo. Sinfo gives you the availability or the available nodes. What are the nodes that are available for you to compute on? You can use S control show partition equal to standard. What's that? This gives you a lot of information about the specific queue. The name of the queue or the names of the queue on the HPC are two, are standard and free. Standard are the queues where you get charged. Free are the queues where you implement any software or any batch mode job in a free way. With the free queue, you are risking that your job will be terminated at any time without any prior notice. With the standard queue, your job will not be terminated. However, you will be charging your quota or the lab quota. Okay? So that's why I'm kind of confused about creating an account, Abdurrahman, without being assigned to a lab. Have you ever tried to submit a job to the standard? Yeah. Okay, we will discuss this after. SA or SACT job ID, whenever you submit a job, you will get an ID for that job. It's a specific identifier for this job, okay? It's a unique number, it doesn't change, and it's actually a counter that is being increased all of the time. So this gives you information about this job number. For example, if you submitted a job and you would like to know, is it suspended, is it finished, what status is the job is in, okay? You can write this command line and it will give you a lot of information about the job. SQ minus U and Khalifa. What's that? This is a command that gives you the status of all the jobs that are submitted by your UCI net ID. So in other words, you should remove N Khalifa by your UCI net ID. This will give you a table or a list with all the jobs that you submitted. This one will give you one line with the specific information for a specific number for the job that you asked for. S bank balance statement minus AN Khalifa. This shows my balance. What's that? Because as per my knowledge, every student is being assigned to a lab, and every lab has a coordinator. Okay? The lab must be created through an advisor or a PI or a professor at UCI. And then that advisor or that professor assigns one of the students in the lab to be a coordinator. This coordinator has the authority to actually divide the lab total quota on the students of the lab. For example, if we have 10 students inside one lab and we are assigned 200,000 computational power for free at the beginning of the year, then he can assign it that each student takes equivalently, so each one takes 20,000 computational hour. So your quota, or whenever you do any simulation, you are charging your quota. So your quota, this command gives you what's the lefting balance inside your quota, okay? But what if you would like to know the balance of the whole lab? You can just write this. This could be convenient or important, for example, for the coordinator, okay? So I think, because I'm the only one in my lab, I think I'm the coordinator, and I think my quota is the lab quota. But I think my colleague here, Abdurrahman, should be added to our lab. You are not in the lab?
I check this one, your name and
Seriously? You should be added to that, man.
you are the coordinator.
No, you should ask them. And I don't know how to do it, but let's figure it out after the. But no, if I allowed you in, you're gonna use the quota, man. I have the luxury to use the whole lab quotas now. So. Oh, I forgot about. Okay, anyways, so let's continue. So now this is another command, df minus h tilde. It gives you the home 50 gigabyte quota usage. What's this constraint? Remember in the picture for the HPC, there used to be a home directory and the storage directory. This storage directory is the place or the directory or the folders where you could store your large files. You get 1 terabyte in that storage thing. Okay, you can save whatever you like there, put movies, anything, you can do whatever you like there on 1 terabyte. But for your home directory, you cannot store more than 50 gigabytes. If you have more than 50 gigabytes in your home directory, you will not be able to do anything through the HPC. Everything is going to freeze. It's going to stop. You cannot submit a job. You cannot do anything. Okay. But sometimes it's convenient to put the case file in your home directory, and sometimes you forget about how many case files that you have. If you are doing a 3D simulation and they are very large, you might sometime reach the 50 gigabyte limit on your home directory without knowing, and this command gives you how much is left in that 50 gigabytes, so you do not face this situation. Okay. sbatch, that's the most important command in the slurm, which is to submit a job file. Now, this line, you get to write it again in the black window screen that we showed before after you are logged in, and you just write sbatch. You need the name of the file. This means that there is going to be another file, and the extension of that file is .sh. It's not .jou. Remember, the journal files are only for Fluent, but now the bash file or the .sh file are for the scheduler. This file is going to be the input file to the scheduler to tell it, please prepare this environment for me. I need 50 cores. I need 10 gigabyte frames. Give me 6 hours. This is my account. Charge my lab. Send me an email. All of your declarations that you would like to prepare for that specific job, you write it in this bash file. And then after you write it, you ask, or you write in the bash file at the end of it, please load Fluent, and then you write that line of the text user interface, open Fluent, take that input file, perform the simulation, and that's it, done. Okay, so this is the most important file or line in the Slurm scheduler or dealing with the HPC. Well, let's say, for example, you submitted a job and you'd like to cancel it. You don't want Fluent or whatever your job to keep executing and charging your quota, and you are not going to use this by the end of the day. So you would like to terminate it, like force it to cancel it. You just use that scancel command and enter the job ID. This is a useful command. It's called module eval. It shows you the installed softwares on the HPC, and it shows you the softwares that are being loaded in your home directory. Think of your home Think of your home directory on the HPC as if it is your home directory on the Linux machine or the C drive on the Windows machine. This is your small piece of computer on the HPC. You actually get to install softwares specifically or privately for you only on that home directory, and they will not be accessible to other users on the HPC. Okay, and they have a manual on the website of the HPC website how to do all of these scenarios. srun a blah blah blah, all of that. This line asks for an immediate interactive node. Remember, guys, we had interactive nodes and we had batch nodes. If you would like to perform an interactive job, which means that please give me an interactive node, they will assign you an interactive node, and then whatever we did on our Linux demonstration where we dealt with the Fluent in a text user interface in an interactive way, you can actually do it interactively. You will be writing commands and Fluent will be replying to you. All of this is happening through that black screen, but you will be redirected from the login node to the interactive node. But however, I have to give you a disclaimer here and an alert. Interactive nodes are only encouraged to be used for testing, for setting up a job, for installing a software, if you would like to install a software in your home directory, etc. You cannot run an extensive job on an interactive node, because actually on the interactive node you are dealing with it as if you are dealing with your personal computer. You get only to use the resources of that node. If you think you can do a job on an interactive node asking for 500 cores, this is impossible, because this interactive node does not deal with those other cores on the schedule or the slurm. Okay, so all of this, by the way, is explained on the website of the HPC, but I'm trying to make it smoother or summarize it for you so I can save you some time and share my experience. While dealing with the black window of the slurm or the command or the command window or the terminal window, you might see that some Linux commands are useful. You can use some of these. One of them is just change directory, because now in that black window there is no folders. You cannot double click on a folder to go inside a folder. You cannot do that. But you would like to move from the directories. CD is the command in the Linux to change directory. And ls is list files. You can list the files inside the directory. And by the way, if you can just Google the most famous Linux commands, and actually these commands are not the Linux commands, I think they are DOS commands, but anyways, if you just Google them, you can find a simple summarized list for the most famous commands that you would like to use or help you in Linux, on dealing with Linux. For example, there is a useful command for copying files. You can copy file from one directory to another directory, and it keeps going. Okay, but keep in mind that you don't have full authority over the Linux machine of the HPC. For example, for advanced Linux users, you cannot have a sudo authorization over the HPC. If you write sudo, you will not be able to do it. Okay, so this was a hint for advanced Linux users. This leaves us with the most important step, which is the bash file. We would like to create that bash file to submit a job and get it done. Now, that is the bash file. So this is the declarations in the bash file. Whatever is above that blue line is for the scheduler, for the slurm. Whatever below that line is for whatever you are trying to do. And as you can see, it's very easy and it's very simple. For the Fluent, this is the line that I just showed you earlier, guys. Fluent, 2D double precision, minus T, I should list here the number of cores. If I'm asking for 5 cores, I should list 5 cores. But however, because the number of cores that I'm asking for will be changing based off the number of tasks that I will be asking for from the slurm, it's a good way to have this declared instead of just making sure that the number is written here is same exactly here. Okay, because with a lot of cases you could get confused, and for example you might ask for 5 cores, but you can have here 10 cores and Fluent will not open because the environment that the scheduler prepared for you, as if you are running Fluent only on a computer with 5 cores. Okay, and without the graphical user interface, this is the input file and we are done. And module load, please load the ANSYS module, open ANSYS, or this is the already pre-set up or pre-installed software on the HPC, and just that line that we used to do. However, the experience or the knowledge comes in here. Okay, you need to declare most of this stuff, if not all. The first thing is the name of the job. This is the name of the job or the title that you will see when you use the SQ command in the slurm window to check the job status. This is my lab account to charge, HE Taha lab. My professor is Haitham Izzat Taha. So this is the lab where I get to charge my simulations to. This is the queue. I charge the standard queue. So the standard queue is the one that we pay for the computational time, and our job does not get to terminated without any period notes. You can change that standard to free. You're more than welcome to do that. And I'm asking for one node. What does that mean? So since we have multiple nodes, and that scheduler is trying to give you your request at the fastest way possible, you could ask for example, 10 processors, but those 10 processors or those 10 cores could be assigned to you, to the slurm, not on the same node, not on a single machine. For example, 2 processors from machine 1, 2 processors from machine 2, and 6 processors from machine 3. And these processors communicate with each other through a very fast network that's are much faster than the clock speed of the processor, as not to slow that communication process. And you get to execute your problem or your Fluent software on 3 different nodes, not on one node. To be able to do that, this means that Fluent must understand or be notified before opening its parallel environment that, hey, please, you will be working with a Slurm scheduler, and that Slurm scheduler is assigning you 3 different nodes, and these are their names. Unfortunately, ANSYS company did not have the Slurm support till 2021. So while I was doing this effort, I was using the 2019 version and the 2020 version. And UCI made that transition to the new Slurm scheduler in 2020, yes, I think late 2020, and the version of 20. So anything that is older than 2021 cannot be operated or cannot be run in a Slurm or with a Slurm cannot be run on a Slurm scheduler with a convenient way or conveniently, okay? So that's why, unfortunately, I'm asking the scheduler to please, okay, hey, forget about that communication between processors, and please assign me one single node. I need one single computer. And most of the nodes at the UCI HPC, they are composed of around 48 or 52 cores, 52 processors, which is a big plus compared to our local machines, okay? So that's why I ask for one node. If you were able to convince the HPC guys to set up the latest version of the 2021 or anything beyond that, that will be a big plus to all of the UCI students, because it will be available now to all of us. However, if we cannot do that, then we have to set up the new version in our home directory, so it will be available privately for me and you and you and you, and each one of us has or his or her own installed version of that Fluent that communicates with Slurm. It has to be 2021 and beyond that, okay? But unfortunately, I'm just asking for one node, okay? And then I'm asking for the memory, 2 GB of RAM, because this is a small case, and the number of tasks, I'm asking for 10 processors. Usually I had this to be 48. This is as an example for you guys. And you can declare this if you wish. Most of the time I don't declare it. This is the time limit. So give me 6 hours. This means that even if Fluent did not finish in 6 hours, your job will be terminated by the scheduler after 6 hours. And Fluent will not be able to save the current status, as if someone just closed that terminal on your local machine, okay? So this is a little bit tricky while you use it. Most of the time I don't declare it, just leave it. You will be assigned time as long as your case is running, and you are charging the standard queue, not the free queue. This is a constraint. This is was very important when I was doing simulation. This constraint asks for that specific architecture of the processors. This architecture is the one used by the Intel processors. Why is that? Because in older versions, when I used to run ANSYS or Fluent on an EPYC processor, which is an AMD processor, it used to be very slow, like even slower on my machine, and I don't know why. This could be related to the architecture of the hardware of the processor and how the parallel MP or architecture that is implemented in Fluent. So I used to select Intel processors only. So this means that I need one node with 48 processors and with that architecture, specific Intel processors, okay? You might go away with all of this now because things evolved, and I think the HPC performance became much better, and I think that structure became better. This is just error slurm, create an error log file. This is send me an email with this events. When the job fails or it ends, send me an email. And this is the mail user, which is my email at uci.edu to send me an email when my job is done. And then, as I mentioned before, please load the module ANSYS. This is the available setup. You have as well 2020 R2. And this line, we are now all familiar with it. You can just write this line. You have a question?
The line, the file must be inside my directory where I'm logging in.
Which line?
Journal file.
Yeah, that's the very good question. So this is a file. This is a file. You're not gonna write this by your hand inside the black window. So this bash file, which is .sh file, and the journal file, and the case file, and the dat file, all of these four must be in the same directory. And actually, you should or you must go or move to that directory, and you write the sbatch command for assigning that bash file from this directory, as I'm going to show in the demo now. So another thing, no bash file, no HPC. If you don't have a bash file, no HPC. You're not using it, okay? You're using it interactively, or you are using it in a different way, don't know how. So bash file is equal to supercomputer. No bash file, no supercomputer. What's the next? Oh, thank you. But before the thank you, let's go to a demo. Now, okay, I would like to log in. The first step was to log in. I will just close that. And do you prefer this terminal or the other one? I think this one is clearer, yeah? Yeah, okay. So let's go to my home. I will go to my home. I will open the terminal from here. And here it is. I will write SSH at nkhalifa shift at HPC blah blah blah. Just write that inside the terminal and hit enter. It will ask you for your password. I will enter my password. And hit enter. It will ask for the two-factor authentication. I will hit 1. Now I should get a notification on my mobile phone. Click approve, and now I'm logged in. Now let's see what's happened. Here, my location was on my machine. The user Nabil at Nabil Precision 36330 Tower. This is the name of my machine. When I logged in, now I am Nabil Khalifa and Khalifa at login node IL5. So now I'm on the login node. Okay. So now I logged in. I'm on the HPC now. But to submit a job, I need my files to be on a specific place on the HPC. How do I do that? You go to FileZilla. FileZilla is a software that you get to set up on a Linux environment or a Windows environment, and it allows you to create a secured connection through the SSH again, and you see your local PC directory and your directory on the HPC. So for example, I will connect here. Here it is. This is the, I'm creating an already pre-connection. This connection for the user nkhalifa, and the host name is that thing, which is again hpc3 dot blah blah blah, and I will just click connect. because I'm already connecting, FileZilla is asking me to abort the previous connection and go to a new one. I'm just doing this for learning purposes, and it will ask you for your UCI net ID password again, the password that you just used to log into your node. So 291, oh, that's my password. Shouldn't have been saying my password. And you get again the do thing. You hit one and you get another notification. And by the way, this is a very important disclaimer or an attention thing. Let's save it for a minute. Here on the left hand side, you will see the directory of your local machine. You can navigate it. And on the right hand side, you have the directory or your home directory on the HPC. Under my home directory in the HPC, as obvious, you see here .ansys because I'm setting ANSYS. So that's the installed version of the ANSYS software on my small computer on the HPC. This is my home directory. And you have the SSH and the local and another cache files. But the most important thing is that I just create a folder. I call it WD working directory as not to mess all of this hidden files for my convenience of my home directory. I just leave it by itself and I create a directory. It's called it working directory. And here you can create whatever you like. So for example, I will delete that because this is already pre-calculated for you. Sorry for the inconvenience. We had to change batteries. Now I will create a directory here. It's just easy like that. Right click, create a directory, and instead the name of being new directory, I will call it workshop, and I will hit enter. Now I will go here to that directory. Now in the right hand side, I am inside the workshop directory under my home directory, which is working directory, under the home directory on the HPC. What do I need? What do I need is that from the workshop folder on my local PC, which is here, I need my case file, I need my .dat file, and I need my journal file, where the journal file is just go, please read cast file, do all this number of iteration and exit. And the most important thing is that I need my bash file, which is this one. So you need to create another file with an extension .sh. And this file has most of the declarations that I already showed you before. These 4 files must migrate to the directory on the HPC, where I have here cavity, cas.sh, and the journal file. Right click and upload. Now these 4 files uploaded without any other authentication. There is a very important step and a very important note to be able to transform multiple files without entering your password at each time and do the authentication for each file. There is a way to do this automatically inside FileZilla, and this is explained on the RCIC or the HPC3 website. This is a very important step, okay? Now I will go here. I will write ls. Under ls, I will find the working directory. I will cd, I will change my directory to the working directory. And under the working directory, I have the workshop. So I will change it. I will change to the workshop again. And hit enter. Now I'm under the working directory under the workshop. I will hit ls. As you can see, I have here my bash file, my journal file, my case and data file. I'll just write sbatch and HP3, hit tab, hit continue everything, and hit enter. Now you submitted a batch job. This is the job ID. I would like to find the SQ. Here it is, my job number, submitted to the standard, asking for 10 CPUs, and what's its status? It's still pending because of the priority. It's not running, and I can check it again, It's still pending. I don't know why. Maybe I can cancel that job. Okay, and after doing so, sorry about that. When your job is submitted, hopefully, yeah, here it is. It's allowed. They allowed the job. I right click on that thing, on that directory. I click refresh. You will find here slurm.out file. I view and edit this file. You will see here what's being written in the Fluent console. Remember the Fluent console that we saved it to the logout file, and the Fluent console that we see in the graphical user interface is being written here inside that out file. I can refresh again and I can click view edit, discard and read again. Here it is, the Fluent loaded, and it's trying to. I have 10 processors. I ask it 10 processors out of 48 because most of the nodes there has 48 processors, and it's reading the cavity mesh and reading the case file. I can click refresh again, and you will see that the job now is being executed, and I don't know why there is no jobs here. The Fluent should start now executing the iterations, but for some reason it's taking some time. It could take some time for some reason. Meanwhile, I think I could show you how to play a little bit with the here, for example, with the scheduler. Let's list all the module availables.
Can you show us an output file like post-processing that you know how?
What do you mean by output file for post processing?
So you run the solution, and the output is some kind of data, and then instead they want to take it back and you will access it in the machine.
Yes, so actually, one of the things that you can do while running Fluent is that you can ask it to store, for example, the lift value or the drag value in a specific file. If you do so, you will find here that there is another file named something results or whatever you name it inside Fluent, and it's .output file. It's a text file, something like that. You take that text file from your local machine and upload it to the HPC, and whatever software you are doing, whatever Fluent is doing, it's recording that file. When it's done, you can download that file from the HPC to your local PC and you have the results, and that's it.
And this out is compatible with the post-processing.
This what? This .out is a text file.
I want something that's...
So what you're trying to say is that you're trying to post-process, if it's a steady case and it reaches convergence, then you are writing the new case with the convergent solution on the HPC. After the job is done, you download your case and date file again to your local PC, and now the case file and that file, the new ones that you downloaded on your local PC, has the convergent solution and all the number of iterations. You can post-process them on your local PC. Let's, for example, say that you are performing an unsteady simulation and you are saving your case and date file each couple of time steps. So on the HPC, at each couple of time step, you go or you get to save the case and date file, for example, for each 10 time steps, and make sure that while you are saving them, you don't save them in your home directory, so you do not reach the 50 gigabyte limit. You save them on the storage directory, and then when your case is finished, you take all of these case and data files and the original case and data file from the home directory, download them to your local PC, and post-process everything. So in other words, the output from what you are doing on the HPC depends on the type of the software you are running. If you are interested in an output as a text file, if you are interested in a specific extension of your software you are doing it, I don't know. So, but the take-home message is that once your job is done on the HPC, you just download whatever you have finished on the HPC to your local PC. I think I could finish by now, but for example, if you hit module available, this is a command from the Slurm scheduler. you can see this are all the setup softwares. You see here ANSYS 2020 R2, 2019 R2, and if you scroll down, I think it should give me the modules available. Yeah, it's not giving me my modules available because I'm not on my home directory. So if I go out, I click quit. Yes, quit. What's the problem? Oh, or actually CD, I would like to go back to the working directory. CD again to the back to the working directory, and hit from here module available. It should give me the modules available in my user home. I don't know why it's doing that, but anyway, this is the modules available that you can load, and you can play with it. Like let's for example see what happened to my job. Is it still in the queue, or it's running? So now my job is running. That's in the queue. If I go to the FileZilla and refresh again, this output file must be updated. Yeah, here it is. I'm performing the iterations. Okay, so it's very useful to keep monitoring your solution at each time, not at each time, but frequently. Let's, for example, I would like to cancel that job, so I will go to S cancel and just take this job ID, copy it and paste it here and enter it. Then my job is cancelled. If I go to my queue again, I don't have anything in my queue. And of course, you can go and play with the for example, our balance. Let's check our balance, which my colleague is not. I don't know how that. Yeah, here it is. It's HE Taha Lab. It's only me. I've used 6,000 hours. We have 31,000 hours, and you should be listed here, guy. That's why you should. Yeah. What? Yeah. Anyways, so it's a good thing to keep monitoring for that. And I think I'm having that asterisk because I'm considered as the lab coordinator, because I'm the only person in the lab. Anyways, so you get to play with those commands. Like now we have a way or a sense of what should we do to run a case on the HPC from Fluent. And now it's time for the thank you guys.